Today, modern agriculture often operates like an industrial factory. We rely on heavy chemical inputs and the aggressive exploitation of groundwater to force massive yields out of tightly packed, identical crops. Compare that to the origins of farming 10,000 years ago. Early agriculture existed for the sustenance of the local community. Without synthetic fertilizers or deep water pumps, surviving meant establishing an absolute functional harmony with the surrounding natural environment. This creates a historical problem. Our ancestors spent millennia testing and perfecting complex environmental conservation strategies. Without written language or journals, they needed a way to document and preserve that research for the next generation. Their solution is known today as indigenous technical knowledge. Early societies developed highly specialized, locally adapted physical tools, and they paired those tools with strict oral traditions to store their scientific discoveries. The folklore, proverbs, and rituals passed down through generations are actually highly compressed data packets. They contain the precise instructions for advanced ecological engineering. By tracking the chronological process of a single traditional harvest, we can decode this forgotten science. We are going to look at the physical hardware, the tools, and the software, the proverbs, used by ancient farmers, and translate them into a blueprint that offers immediate solutions for modern agriculture. Environmental conservation is not a recent concept. For thousands of years, it was baked directly into the mechanical rhythm of survival. The agricultural cycle begins long before any seeds are planted. Land preparation starts during the rainy season, when the ground is finally soft enough to work. This image shows a farmer using a Desi Hall, a traditional wooden or iron plow drawn by bullocks. It's a vital piece of ancient hardware utilized across the region, notable for its low environmental impact. Farmers follow the plow by dragging weighted wooden planks across the mud, meticulously flattening and leveling the ground to prepare an even seedbed. The software controlling this hardware is found in regional folklore. A proverb from the Bagali dialect instructs farmers to wait for the monsoon rains of Assad and to plow the field exactly twice, once crosswise and once lengthwise. This cross-section illustrates the science. By cross-plowing during heavy rains, grooves channel water downward, trapping it deep underground. The field becomes an underground sponge. In the dry winter, this locked-in moisture rises to hydrate crop roots, bypassing external irrigation. The short, simple rhyme about Assad was a precisely engineered water conservation algorithm, ensuring food security through the dry season. Moving into the planting phase, modern industrial farms favor vast single-crop monocultures. Traditional farming utilized crop rotation and complex mixed planting. This grid shows a folklore rule for spatial geometry. Sorghum stalks were planted a frog's jump apart. These gaps were intercropped with bush plants, creating a multi-tiered canopy. Underground, chickpea root bacteria pull nitrogen from the air, providing continuous organic fuel for the sorghum. After the harvest, the leftover stalks of intercropped plants, like kodo millet, are left in the field to rot. As they break down, they refertilize the earth for the following year's planting cycle. By strictly following a proverb about a frog's jump, these communities engineered a closed-loop living network that entirely eliminated the need for synthetic chemical fertilizers. When extracting the yield, the hardware changes. This image shows the hasua, a traditional handheld sickle. Its curved blade allows the farmer to selectively gather only ripe stalks, prioritizing manual precision over indiscriminate mechanized clearing. The software governing extraction relied heavily on cultural restrictions. Folklore strictly forbade kicking the kaitha fruit before the autumn festival of Dasera. For medicinal herbs, farmers were mandated to offer a prayer to the plant before uprooting it. Tying a harvest to a specific late calendar festival date ensured that the plants were left untouched until they reached full chemical and medicinal maturity. Performing a ritual prayer or touching the base of a tree before climbing it functioned as an artificial speed bump. It slowed the human extraction rate, forcing the farmer to harvest selectively rather than stripping an area bare. These religious taboos operated as an ancient regulatory agency. They guaranteed non-destructive exploitation and kept local plant lineages intact. Today, this ancient database of ecological science is actively being overwritten and forgotten. This ethnological research paper, which explores the heritage of tribal farmers in the Ajodia Hills, documents a rapid extinction event. The deeply specialized, ergonomically adapted agricultural tools of the region are disappearing. This radar chart maps out traditional tool usage by the age group of the farmers. The demographic crisis is clear. Younger generations are abandoning physical tools and the accompanying indigenous technical knowledge, pivoting entirely to mechanized, fuel-reliant alternatives. When the physical hardware vanishes from the fields, the deeply encoded ecological rules attached to it vanish as well. The solution is not a complete rejection of modern technology, nor is it a romanticized return to grueling animal-powered labor. Instead, we can integrate modern scientific ergonomics with traditional tools, improving their physical efficiency while preserving the ecological function they were designed to perform. Modern industrial farming can adopt the philosophy encoded in ancient software. By utilizing dynamic, science-based crop water budgeting and dense mixed planting, we can replace the brute force of chemical sprays with intelligent, self-sustaining biology. True sustainability requires precision, patience, and a deep respect for local topography. To secure the future of our food supply, we must stop treating the farm as a factory and start treating it as the